Good day, students. Now consider the next topic, named the mode and the median of the continuous random variable. Mode in Azeri is moda, median, median. The mode and the median of the continuous random variable in Azeri is kesilmez təsadüfi kəmiyyətin modası və medianı. The mode is denoted as MO by means of MMO, and the median is denoted ME. According to definition, the mode is such a value of the continuous random variable at which the distributive density has the greatest value or the maximal value. For finding the mode, first we must find derivative of the distributive density f little of x, then equalize the obtained derivative to 0, and solving the obtained equation we can find the critical points and then extreme points, and after finding the maximum point, we can say that this maximum point is the mode of the continuous random variable. Then go to the median of the continuous random variable. Here the definition of median of continuous random variable is given. If the integral from minus infinity to a of f of x dx is equal to the integral from a to plus infinity of f of x dx, then the point a, the integral limit a, is the median of the continuous random variable. Now calculate the value of each of these integrals. For this, remember the basic probabilistic equality. It is basic probabilistic equality. What is basic probabilistic equality? In Azeri it is esas ihtimal beraberliği. Then separate this integral into two integrals from minus to a and plus integral from a to plus infinity. But according to the definition of the median, this integral is equal to the second integral, right? Second integral. Then we can write integral from a to plus infinity f of x dx plus integral from a to plus infinity f of x dx is equal to 1. But we have the same integrals, therefore we can write twice integral from a to plus infinity f of x dx is unit. Then this integral is equal to integral from a to plus infinity f of x dx is equal to 1 second. But this integral is equal to the first integral, and the left integral is also equals 1 second. Well, here we have integral from minus infinity to a of f of x dx equals 1 second. 1 second. These formulas are used for the calculation of the median of the continuous random variable. It means we can define the median of the continuous random variable by two methods. One of it is first method, but it is second method. And in the solving the next examples, we will use both methods of the finding the median of continuous random variable. Then let's consider the next topic, named the median of the continuous random variable with the symmetric distributive density. What is symmetric function? What is symmetric function? Already you know the definition of the symmetric function, and here we must the following theorem: if the distributive density is a symmetric function, and if A is the symmetry center, then the median of the continuous random variable is equal to the symmetry center. Theorem. Theorem. If function is symmetric, f of a minus x is equal to f of a plus x. That is, if f of x is symmetric function, that is condition of function symmetry. Here a is symmetry center. Symmetry center. Then the median of the continuous random variable is equal to the symmetry center. Then median is A. Median is A. We must prove this formula. Symmetry center. You can write also center in the following form. It is American form, but it is British form. Center. Proof this this fact, this result. Proof. What is proof is in other is ispat proof. Use this fact that we must use here the definition of the median, and we must prove that integral from minus infinity to a of f of x dx is equal to integral from a to plus infinity f of x dx. Consider the left integral, and then must prove that the left integral is equal to the right integral. Begin. Integral from minus infinity to a f of x dx. Let hold the first change. Right here, first change. Let x is a minus t. Change x by a minus t. Let x is a minus t. Then t is a minus x. A minus x. Then find dx. Dx is d of a minus t equals it is differential according to the definition of differential. Differential is equal to differential of some expression is equal to the derivative of this expression multiplied by the differential of the independent variable. But also you know that the difference of the differential of the difference is the difference of the corresponding differentials. It is dA minus dt. Here a is constant value, and you know that differential of the constant value is zero, and it is 0 minus dt, and it is minus dt. Then also change the integral limits. This integral limits is used only for the variable x, but for the must find the corresponding integral limits for the new variable t. The low integral limit for x is minus infinity. If x is minus infinity, then we can find the value of t. If substitute minus infinity instead of x, we will obtain a minus infinity is a plus infinity, but a plus infinity is plus infinity, because if add the constant value to plus infinity, then we will obtain again plus infinity. T is plus infinity, and then consider the upper integral limit. If x is a, then substitute a instead of x here. A minus a is 0, then t equals 0. Then use this first change. Integral from plus infinity to 0 f of a minus t multiplied by minus dt, because dx is minus dt. Then we can take the negative sign out of the integral symbol. Minus integral from plus infinity to 0 f of a minus t multiplied by dt. Then further, if change the places of the integral limit, then the given integral will change on sign. If change the places, then we obtain add the negative sign to the given negative sign, and then we will obtain positive sign. Plus integral from 0 to plus infinity f of a minus t multiplied by dt. Then use the definition of the symmetricity of given function. According to condition of our theorem, the given function f of x is symmetric function. Therefore f of a minus t we can change by f of a plus t, because this function is symmetric with respect to point a plus t. Then we will obtain integral from 0 to plus infinity of f of a plus t dt. Then continue. Then continue calculation of this integral, and now realize the second change. Let change a plus t by new variable x. Let a plus x is x. A plus t is x. Then here, from here, t is x minus a. Then dt is d of x minus a, then it is dx minus dA, and you know that dA is 0 because a is constant value 0, and then we will obtain dx, simply dx. Now change the integral limits because this integral limits is used for variable t. And now we must find the integral limits, the values of integral limits for the new variable x. If t is 0, then substitute 0 instead of t in this equality. A plus 0 is a, then it means x is a. And if t is plus infinity, it is upper integral limit, then a plus infinity is simply plus infinity. X is plus infinity. Then use apply the second change to the last integral. Integral from a to plus infinity f of x dt is dx. Finally, already we obtained that integral from minus infinity to a f of x dx is equal to integral from a to plus infinity f of x dx. That is a, here a is media, but a according to condition is also the symmetry center. And according to the result of theorem, in this case, the media of the continuous random variable will be equal to the symmetry center A. Now consider the examples on median of the continuous random variable, and we will calculate the median by two methods, by means of two obtained integrals, and each of these integrals is equal to 1 second. Example, right example. Now consider example. Find the median. Find the median of the continuous random variable with the distributive density. What is distributive density? In other, it is paylama sıklığı. Distributive density f of x is 1/4 in the interval minus 1/3 and f of x is equal to 0 outside this interval. Solution. consider first method. First method. Use one of two formulas for the calculation of the median of continuous random variable. First formula is integral from minus infinity to a f of x dx. dx is 1 second. Here we must find the value of a. The value of a. The value of a. Then continue. First, construct the intervals. The real axis is given. Real axis, and mark the points -1, 3. We have three intervals. First interval, second interval, and third interval. Between -1 and 3, f of x is 1/4. But to the left and to the right of this interval, the distributive density is 0. Then, you must know this fact that the median belongs to the interval of non-zero value of distributive density. That is, median belongs to this interval -1, 3, because in this interval f of x isn't equal to 0. A in this interval, A must be to this interval. And here integration is held from minus infinity to A. Minus infinity to A. It means we have two integration intervals. And we can rewrite this interval in the following by means of two intervals. Integral from minus infinity to -1 f of x dx plus integral from -1 to a f of x dx, and it is equal to 1 second. In the interval from minus infinity to -1, our function f of x is 0, and you know that the definite integral of 0 is also 0. But but interval from minus to a belongs to the second interval from -1 to 3, and here f of x is 1/4. Integral from -1 to a of 1/4 dx is 1 second. 1/4 is the constant factor which can be taken out of the integral symbol. We have 1/4 multiplied by integral from -1 to a, dx is 1 second. In this integral, the integrand in other is integrale functie, integrand is unit, and the antiderivative iptai functie, antiderivative is x, right, 1/4 multiplied by x with double substitution from -1 to a is 1 second. Then first substitute a instead of x and subtract, then substitute -1 instead of x. 1/4 multiplied by a minus -1. It is 1 second. Then continue, then continue 1/4 multiplied by a plus 1 is 1 second, then a plus 1 is 2, will be 2, a plus 1 is 2, and a is 1, It is our median, median of the given continuous random variable. Then find the median by the second method. In the second method, write second method. In the second method, the following integral is used. Integral from a to plus infinity, f of x dx. dx is equal to 1 second. Then continue. Now construct the intervals for the second method. From minus infinity to plus infinity. Here f of x is 1/4, f of x is 0, and here f of x also is 0. In the second method, the integration is held from a to plus infinity, and you know that the median must belong to the interval in which the distributed density isn't equal to 0. A situated between -1, 3. Integration is realized from a to plus infinity, and now we have two integration intervals, and therefore we can separate the given interval. Integral from a to 3, f of x dx, plus integral from 3 to plus infinity, f of x dx, is equal to 1 second. Integral from a to 3 belongs to the second interval in which f of x is 1/4, and therefore we can change f of x, substitute 1/4 instead of x in the f of x in the first integral. But in the interval 3 to plus infinity, our function f of x is 0, and the given integral of 0 is 0. Therefore, we will obtain integral from a to 3 of 1/4 dx is 1 second. And then continue. Here 1/4 is constant factor which can be taken out of the integral symbol. Continue. 1/4 multiplied by integral from a to 3, dx is 1 second. Here the antiderivative is unit, integrand is unit, and its antiderivative is x. 1/4 multiplied by x with the double substitution from a to 3 equals 1 second. First substitute 3 instead of x, then subtract and then substitute a instead of x. 1/4 of 3 minus a is 1 second, 1 second. Then 3 minus a is 2, 3 minus a is 2, and a is 1. And you know that we obtained the same result, and here the value of median is verified. Then let's consider the next example. Consider next example. Example 2. Find the median and of continuous random variable with the distributive density f of x is equal to x minus 1 second in the interval 1, 2, and outside this interval f of x is 0. f of x is 0 outside. Find the median. Median is equal to question. Solution. Use the first method. Use the following equality: integral from minus infinity to a, f of x dx is 1 second. Which is first method for the finding the median of the continuous random variable. Construct the intervals. Plus infinity. 1 second, 1, 2, and a is situated between 1 and 2, according to the definition of the median. But here we have 3 intervals from 1 to 2, and also to the left of this and to the right of this interval. In the middle interval, f of x is x minus 1 second. To the left, f of x is 0, and to the right, f of x is also 0. In this integral, the integration is held from minus infinity to a. And we have two integration intervals. First integration is held from minus 1 infinity to 1, and second from 1 to a. Integral from minus infinity to 1 f of x dx plus integral from 1 to a f of x dx is equal to 1 second. In this integral from minus infinity to 1, f of x is 0. Therefore, we must equalize f of x to 0, and definite integral of 0 is 0. In second interval, interval from 1 to a belongs to the interval from 1 to 2, where f of x is x minus 1 second. Therefore, we can change f of x by x minus 1 second. Then integral from 1 to a of x minus 1 second dx is 1 second. Here integrand is x minus 1 second, and its antiderivative is x squared in half minus x in half, or x squared minus x in half. X squared minus x in half. It is an antiderivative for the function x minus 1 second. You can check this result. If differentiate this expression, you will obtain x minus 1 second. And add the Dow substitution from 1 to a equals 1 second. Multiply the both parts by 2, then obtain x squared minus x, the substitution from 1 to a is unit. First, substitute a instead of x, a squared minus a, then minus, and then substitute 1 instead of x. 1 squared minus 1 is unit. It is 0, and then transfer unit to the left part. We will obtain a squared minus a minus 1 is equal to 0. It is quadratic equation, and for finding this equation, first we must define the discriminant. Discriminant is equal to discriminant 1 plus 4 is 5. Then find the root of this equation. A first second equals 1 plus or minus square root of 5 over 2. Consider first root. A1 equals 1 plus root of 5 and a half. Approximately is equal to, the square root of 5 is approximately to 2.2. 1 plus 2.2 over 2, it is 1.6. 1.6, and it belongs to our interval from 1 to 2. It means it is the median of the given continuous random variable. Then check the second root. A sub 2 equals 1 minus square root of 5 in half, approximately equals to 1 minus 2.2 is minus 1.2 divided by 2 is minus 0.6. But minus 0.6 doesn't belong to the interval 1 from 1 to 2. It means the number 1 minus square root of 5 in half isn't the median of the continuous random variable. It is answer. Then go to the second method. Then consider the second method. Use the second equality for the median of continuous random variable. Integral from a to plus infinity. F of x dx is 1 second. 1 second. Again construct, draw the intervals 1, 2 and a between them. Minus infinity to plus infinity. Here f of x is x minus 1 second, here f of x is 0, and also in the right interval f of x is 0. In the second method, the integration is held from a to plus infinity. And we have two integration intervals, and therefore we can separate the integral into two following integrals. Integral from a to 2 of f of x dx, plus integral from 2 to plus infinity f of x dx is 1 second. 1 second. In the first integration interval from a to 2 belongs to the second interval in which f of x is x minus 1 second. Therefore, we can change f of x by x minus 1 second. And interval from 2 to plus infinity is the interval in which f of x is 0. And definite integral of 0 is 0. And then we can write integral from a to 2 of x minus 1 second dx is 1 second. Already you know the antiderivative of x minus 1 second, it is x squared minus x in half, with double substitution from a to 2 is equal to 1 second. Then first substitute 2 instead of x, and then substitute a instead of x. 2 squared minus 2 in half minus a squared minus a in half is equal to 1 second. Then we can multiply both parts of the last equality by 2. Then we will have 4 minus 2 minus a squared plus a is 1. Then transfer all terms to the right. 0 equals a squared minus a minus 1. And already we know the rules of this quadratic equation, because this quadratic equation is used in the first method. Then the first a1 is 1 plus square root of 5 in half. It is approximately equal to 1.6, and it belongs to the interval 1, 2. It means the number 1 plus square root of 5 in half is the median of the continuous random variable. And test the second root. Second is 1 minus square root of 5 in half. It is approximately equal to minus 0.6, which doesn't belong to the interval 1, 2. It means this number isn't the median continuous random variable. Our answer is verified, and now please write your homework. Write homework. The distributive function f of x is plus 1 second. I'm sorry, f of x is equal to x plus 1 second in the interval 0, 1. 0, 1. And f of x outside. D0 outside. Outside. This is the interval. And find the median. Median. Find the median. Our lesson ended. Goodbye, students. Good luck.